Hello, welcome to the Studio 2, the first talk of the Studio 2 for today. I'm Dmitrii. I'm acting as host for this particular talk, but honestly, I'm not only host today. We are together with Paul.
Hello, everyone.
Yeah, we are going to together talk about IntelliJ IDEA and how it's integrated with Gradle. Basically, here is our talk name, yeah? So Paul Merlin is a principal software engineer at Gradle. My name is Dmitrii Smirnov. I'm product manager at IntelliJ IDEA. I kind of focusing on build tools integration, so we are kind of working together.
We do.
Yes, a lot. And we are going to go through a couple things today. Yeah. So what are the plan? The plan is basically we will go you through a typical project lifecycle and how Gradle lives there. Yeah. What is lifecycle? Opening, doing other stuff. So a bit later about that. So once we go through lifecycle, explaining you how things works Gradle-wise and IntelliJ-wise, we would also, like in the process, show you some sneak peeks. Like we are together using the nightly build of IntelliJ IDEA with some features we are currently working on that are not yet available anywhere, even in AAPs. We would also like to discuss how we actually collaborate with Gradle, not only me and Paul together, but like as a companies, as a teams. And give you an overview of major projects, major directions, and future plans. So that's the idea for today. And let's go with the life cycle. So what's a life cycle project? Yeah, obviously to start working with it, you need to clone and open it. Otherwise, like, how can you work this? Well, once the project is opened, well, everyone saw that. What happens is actually a project sync. And we are going to explain what the thing is, why it is useful, actually why it is needed, not only useful, but why it is needed in the first place, and what it brings you. Well, then you can run, then you can do some changes, test, obviously. It's a good practice to test your changes, right? Debug sometimes, and sometimes is not clear. And that's kind of the main part of development. But there is one more additional thing that maybe is not an everyday task, but you definitely sometimes need to configure your Gradle build properly. Here we also have something to talk about, and this will also cover it with some live demos. So, to the project thing. So here we see kind of an overview of architecture of the thing. Yeah, we see there are two things kind of talking together. And let's start with the Gradle side. Paul, could you please
thank you,
shed some light?
So yeah, like Dmitrii said, you see on this diagram IntelliJ IDE on the left, Gradle on the right, and two arrows in the middle. The main thing to understand here is that IntelliJ IDEA pushes what we call model builders. It's actually code to Gradle that will run inside Gradle and gather data from the configuration of the build and so on, and create models that will be returned back to IDEA for doing its work. And here, Gradle is the source of truth. Gradle knows about the structure of your build, how many projects you have, their names, where sources are, what are the dependencies, and so on. All the data about your build. And this is possible thanks to a feature of Gradle, which is called the Tuning API, or TAPI for short. It's kind of a RPC mechanism that allows tools to invoke tasks, run tests, and like here for Project Sync, inject code to gather data from Gradle.
Yeah, so it's not only specific for IDEA, right? So Tuning API.
Yeah, no, there are other tools like continuous integration servers that actually use the Tuning API to invoke Gradle, or the GitHub dependency graph submission action that uses the Tuning API to gather metadata about the dependencies to submit the dependency graph. So it's not only limited to IDE.
Yeah, but we are happy to have it, not to run Gradle on command line and parse outputs then, right?
Indeed.
Yeah, so on the Gradle side, IntelliJ IDEA actually pushes some code inside it. So it's IntelliJ's code that we run on the Gradle daemon to extract data we need. And what is that? So on IntelliJ side, we have the IntelliJ Gradle plugin that basically serves as a communicator with the Gradle, right? It has its own requirements to get. It can be also extended. For example, if you have Kotlin plugin has other requirements and other knowledge needed from Gradle to get. Android plugin also might need something specific, so they kind of extend what IntelliJ Gradle plugin requests. And
for example, Kotlin has this notion of friendships between sources, so that like test sources can access internal members of main sources. And this is something that the Kotlin plugin in IntelliJ asks to Gradle.
Without Kotlin, we don't ask this information. An obvious example, what we ask every time is actually source sets, right? Well, so what's trying to convey here is actually that we have several sets of information needed, and for each of these sets we run separate model builder, and there may be several. And we collect from each of them, we collect information back. So this schema is only first step of actually what sync is. So we get raw data from Gradle. What happens next? With all these models we got from Gradle, we kind of merge them together to build an IntelliJ project model. What it is like, well, basically it's a project structure you see in the project tree. For more details, if you open up the project structure dialog, you see there what models are there, how they basically depend on each other, what binaries dependencies are there, and so on, all the stuff. So this is a project model. And why we need it? Well, we obviously need it to provide all the features we have, because all the highlighting, all the code navigation, especially like all the inspection and fixes, refactorings, it's all relies actually on the project model. So basically, the sync is needed to get that project model in the most accurate and robust way, so you can work with any project inside IDE and be sure that you have all correct stuff and it like navigates you in the proper place. But what could go wrong? Sometimes it takes a while. And there are reasons for that. Because it's doing a lot of work, potentially. For example, if you start on a fresh machine, Gradle on this side will have to build the build logic for your build to be able to configure the build, download dependencies, maybe generate some sources, and so on. And then once the models are shipped to the IDE does a conversion, and this model can be large depending on the size of your project. Like if you have thousands of projects with multiple thousands of dependencies, then it's quite a lot of data. But the main problem is that it's an all or nothing process, meaning that if there is a failure somewhere during that process, everything fails. The IDE doesn't get the models at the end. But stay tuned, we have future plans around this, and we will talk about them later. So that's what Project Sync is in a nutshell. But it's nice to talk, but how actually it is useful in a real life, Let's switch to Paul's laptop so we can show you some demo of what actually Sync brings us.
Thank you. So here you see IntelliJ, and like Dmitrii said, it's a
nightly build.
It's a nightly build. So this is not available yet for you, but some of the things we will show are not available yet, and we will point at them specifically. So for this demo, we will use the Spring Pet Clinic project again. And the first thing that happens when you open it, you can see it here at the bottom, is that IntelliJ is importing the project. That's the project sync, right? And the first thing we see here about this is that in the directory tree, IntelliJ knows that we have main and test sources, they are highlighted. And it knows that in RCC main Kotlin, it's Kotlin code, production code. Here is test code, right? And this is coming from the data that IntelliJ grabbed from Gradle. And this is also shown in the project structure dialog. All the parameters here are coming from the Gradle configuration. The dependencies, the path to the sources, etc. Everything comes from that. Again, the source of truth. And thanks to that, we have the IDE has the context necessary to highlight the code, to provide the documentation and code navigation, to and from usages, and also because it has all the dependencies, we have the completion. So it's all things you take for granted, right? But they are present for a reason.
Basically, that's the result of a thing.
Yeah. And then on top of that, IntelliJ provides more features to help you work with your code. Like for example, here in the left gutter, we see display button. And it's used to here run our pet clinic application. Simple and easy. But we also have, tests. And for tests, it's the same. We have gutter buttons here. And this is actually running through Gradle, right? And it's again using the same tooling API mechanism to invoke Gradle.
Yeah, and we also get the list of tasks from Gradle.
Right. So here on the right, we have this Gradle panel where we get all the tasks. And if I want to simply run a task, just double click it. And it, again, uses the tooling API to run everything. And this is the way to trigger sync again. And of course, when you just did it, it's very fast. Because I made no change. So Gradle had nothing to do, and the IDE could reuse the same model and so on. All right, so we saw basic features provided there. But let's say we want to make actual changes to our code. So let's say we want to add email notifications to the pet clinic. And for that, we will edit the Gradle file and add the dependency. We know that Spring Boot has the feature for email. So this is a sneak peek of a new feature coming in IntelliJ that allows you to search for available dependencies directly in the Gradle files. And here we see the Spring Boot starter mail. No, not this one, sorry.
Yeah, so
there
it's not properly sorted yet. Yeah, it has multiple ones. So the second one is from Spring Boot framework.
All right. So simple and easy. Like we said, this is not available yet, but will be soon. All right, so we will not try to implement this live, but I just checked it out tag where we have added the email service, some tests, and the integration in the application. All right, so now we have another way to run Gradle, right? It's by the run anything feature in IntelliJ. This is also using the tooling API again. And so I'm going to run all the tests of this app. And oh, it looks like we made a mistake when we implemented the application.
That's why it's always useful to run tests before deployment, right?
Indeed. So we have two tests failing. Let's take a look at what's happening. So the mock HTTP server tells us that the request resolved to an exception, method argument type mismatch. That's not very helpful, right? And there is no error message. This is the page. All right, so let's try to debug this test then. So these two tests are failing here.
And you can see it in the gutter that they are failing.
Yeah, they're red here. Let's throw a debugger at it. We put a breakpoint here, hit debug, and again, this is going through the tooling API to launch the Gradle process, the test process with the debug parameters and so on. All right, we hit our breakpoint. Let's step into perform, and then we need to step over until the request is processed, and that's in the filter chain. Now it's actually doing work, and it's taking a bit of time because it's slower with the debugger attached, and here we go. So now we have the Spring MVC results, and it should have the resolved exception. Yes, let's take a look. Now we have a message. So method parameter owner ID failed to convert value of type string to require type int for input string star. Let's go back to the test. Yeah, this test have a star in the pass here and a pet ID name variable, and they have two name variables there. So there's something fishy here. Let's look at the controller. And this is the post, so it's here. All right, the pass here doesn't have a star. It has an actually named variable that is mapped to an integer. So that's it. So we failed to write the test correctly when we added the new feature. So let's stop the debugger and run the tests again. And again, this is going through the Gradle tuning API. And all good this time.
Yeah, we fixed it thanks to the debugger.
Cool. So it was pretty quick, but we looked at everything you can get out of sync.
Yeah.
For working with your production code and test code, running tasks, running tests, running the debugger, running the application, and so on. And with that, we can go back to Dmitrii's laptop for the rest of the presentation.
Thank you. Thank you, Paul, for the demo. So yeah, as a quick recap, all the features, highlighting, completion, navigation, documentation, list of tasks, running stuff, debugging stuff, it's all possible thanks to that sync. So that is why we need some time to wait a bit to get it working. But it should be worth it. However, our talk is not called like debugging with Gradle, right? It's called IDEA is an IDE that speaks Gradle, right? What actually speaking Gradle is. So let's once again switch to Paul's laptop for another demo where we show you how IntelliJ helps you actually editing Gradle configurations.
All right, so we're still looking at the same project here, so the Spring Pet Clinic. And we're looking at the Gradle build definition, the build script for the application, where we have all the dependencies. We see the starter mail thing we just added. And a bunch of configuration here. Some metadata about the project description, group version, plugins that are applied, basic configuration of Java, the Java version, some Kotlin compiler argument around nullability, parameters for using the JUnit platform, and all that. This looks okay. But let's say in this build we have one Spring Boot application. But we plan to have a second one, like a second service. And we want to extract common configuration that we will be able to share between these two. That's a practice in Gradle that is named a convention plugin. We will extract a convention plugin out of this to be able to later reuse it on another module. It's been a best practice that we advertised for a while. And we'll see how we can apply it with the tools that we have today. And IntelliJ will help us along the way, but we know that there are a lot of room for improvement there.
Yeah.
So it will be a bit tedious, a bit of things to do by hand. But it's good to see and to see where IntelliJ already helps and where it can help more in the future.
And since we're talking about sneak peeks, this is something we are looking at.
Yeah. So before we get there, IntelliJ, just like when you edit production and test code, provides help when you edit Gradle files. For example, we get documentation. Again, it's during sync that Gradle provided to IntelliJ the scope for the Gradle scripts themselves.
Yeah,
just like with
a separate model builder that collects this information. Yeah, specifically for the Gradle scripting and for these features to actually work for you in the same way it works for regular code.
Yep. Yeah. And so we can see that we get the same benefit there. We get navigation to source code and code completion. So about code completion, the Gradle build definition here is in a build.gradle.kts file. So it's Kotlin code. It's Kotlin scripting, right? So when you ask for code completion, you get completion for, just like in Kotlin code, for everything that is available there. And there is a lot available here. And that can be overwhelming. Like, which entry should I use? Like, it's all blurry, it's scrolling too fast. So one thing we want to showcase today that is coming in future IntelliJ version, and this is just a preview for now, is a targeted, restricted completion in KTS files. So for example here, I only see a bunch of blocks at the root.
Yeah, so basically on this level, we wanted to provide only the most important, most popular, like most needed high-level blocks for the script. And it basically considers that some of them are already added. That is why they're not, like, for example, it does not offer you plugins once again.
Or dependencies, because it's already there. And of course, once you get there, you can have the completion for what's nested and so on. So that's very nice. And of course, it's a preview again. So here we don't see the completion for, like if I remove the Kotlin block, I don't see the completion for the Kotlin block because it's, again, work in progress. But the plan is to provide this.
Yeah, it should be fully aware of the context, of applied plugins, of registered repositories, so on.
And again, the Gradle model grabbed through the tooling API during project sync will provide all the necessary information for that.
Yes, it will rely on the Gradle knowledge of what should be there.
So another nice thing we already have is the dependency scopes when declaring dependencies. So here we have only the dependency scopes that are available. We don't have all the Kotlin standard library, all the dependencies.
Yeah, but once again, as we showed you previously, if you are looking for a specific library already, you can just type ahead its name, and it would complete with the entire string, including the correct scope.
Yeah, just like we did before. If I just tap Spring Framework here, I can see all the Spring Framework related things available here. All right, so let's get back to the convention plugin story. I want to extract the convention plugin out of here. So the first thing I need to do is to create a build to host my convention plugins. So I'm gonna simply create a directory, create name build logic here, and in my settings file, I will include build logic. So here I created a build here. Let me add a settings file, which is the bare minimum for a Gradle build. And I will also add a build file. All right. So this new build will need to resolve some dependencies, like dependencies to the plugins our convention plugin will use. So I'm copy-pasting the repositories declaration from the outer build to the build logic build. How to share that is out of scope of this presentation for now, but all right. And we will use the Gradle plugin portal instead of Maven Central to be able to resolve all the plugins. And our build will use one plugin, which is the Kotlin DSL1 coming from Gradle that is used to write plugins in Kotlin.
Yeah. It doesn't help with signing completion yet because it is not sync, and it doesn't have an idea. It's actually Gradle.
Yep. And it tells us that, IntelliJ tells us that here. It tells that we have, the Gradle project structure has been changed. Sync changes with IntelliJ IDEA to make it work correctly. So let's go, let's do that. All right, it's synced and now it's properly highlighted and we get code completion to generated sources here. The settings is now highlighted and so on. And we did sync, and you see this directory now is highlighted as being a code block. So it's now aware that this is a build. Now I'm going to add my convention plugin there, and it will be a Kotlin file. Again, IntelliJ knows that the sources are in SRC main Kotlin thanks to the model coming from Gradle. And now I'm going to create my Spring Boot application.gradle.kts. And Spring Boot application is the name or the ID of my convention plugin here. And for now, it will just print it works, just to make sure it does. if I stop here, nothing will happen, right? I need to apply my convention plugin. So here I'm going back to the Spring application build definition, and I will add the request to apply this plugin. Again, if I sync, I will see in the output that during sync it configured the project, it applied the plugin, and it works. So all this ceremony to add an empty convention plugin. So IntelliJ did help along the way, but we are discussing how it could help much more by automating all this. Good, so we have our empty convention plugin here. We can now start moving things from our build definition here, extract it to the convention plugin. And the first thing we'll do is start with the third-party plugins that we are applying here. In the end, we only want one plugin to be applied here, and this guy to do all the work.
Yes, that's the purpose of convention plugin, right?
Yes. So here we're using Gradle version catalogs, and IntelliJ provides code navigation to them and back. I can navigate to my version catalog and say, okay, who is using this library? And I navigate here and back. So here we define the version and the IDs for all the plugins we use. And we want to reuse that in our conventional plugin. So to do that, we will tell our build logic build to use a version catalog named libs from file, almost there, and we use the version catalog from the outer build. Let's sync so it gets aware of that. And then now in the build script for build logic, we will add dependencies to these plugins. To do that, and to reuse the version catalog entries simply, we need some helper that is coming from the Gradle documentation currently. No, it's plugin dep. Right. So
it's a live template we did, so it doesn't expect it to be a specific feature. A live template.
It's a live template we just added, and this snippet is actually documented in the version catalog documentation in Gradle. Something to be improved, to be like shipped in Gradle proper or something like that, but for now we have to use that. And so we want to add these plugins as dependencies to our build logic. So it's an implementation dependency, right? Here we use our helper, and then we will use the version catalog plugins. Yes, Spring Boot.
And there is a completion, again, thanks to the thing.
Yeah. We want Google Jib, and we want Kotlin JVM and Kotlin Spring. And we have the 4 plugins that we have here. So now we added the dependency here in our build logic. And now we will want our convention plugin to actually apply these plugins. Right? And here we need to reference them by ID only. So this is a bit, again, a bit tedious, but that's the way it is for now. So I'm gonna use my muscle memory and train it again.
Yeah, here's an obvious place that could be a bit automated.
Yeah, there is room for improvement, indeed. A few more seconds. Please be patient. All right. So now my convention plugin is applying the plugin. So I can remove them from here, right?
Should be fine.
Should be fine. Let's see. Let's go sync again. Sync did not complain. And I can still run my tests just to make sure everything works. Yep, all good. So here, first we created the empty convention plugin. Then we moved all the plugin applications there. Now we can start doing the real work. The real work being extracting the command configuration. So this, for example, the Java version, Kotlin compiler option, and JUnit platform usage, we can just cut it from here and put it into our conventional plugin. And that's it. Now I can sync again and enjoy a shorter
Main
build definition here. And if I need to add a new Spring Boot application, and I can just reuse this one. But there are some other things we could do, like this jib configuration could also go to our conventional plugin. But there is one tiny thing here, is that it named the Docker image by the project name. So here, let's use the project.name instead. Then when we use that conventional plugin to another application, it will correctly name the Docker image. And here we're left with the dependencies. We could move using the Spring Boot BOM also to our conventional plugin there, and leave the dependencies. We could go further and extract common dependencies and so on, but that's already plenty enough. All right, so we're done with extracting our common configuration to our conventional plugin.
Yes, so now we have a more concise main configuration of the project.
Yeah.
Like if we have many, it will save us a ton of lines of code.
Mm-hmm.
And this is a best practice, which we want to promote. And Gradle has been talking about it for some time. But more about best practices a bit later.
And one good thing is that now this looks very much declarative. I'm only declaring some metadata of the project, declaring that this is a Spring Boot application and the dependencies. So it's much easier to read and understand. But one thing we can do if we go on with this and to showcase another thing that is coming in next IntelliJ IDEA version.
Yeah, one more sneak peek for you.
Is to add, let's say we want to add a static code analysis to our project using the detect plugin. In the plugins block, I can now just type detect and I get completion from the plugin portal. And just hit enter and I'm done. And now I can run detect and it actually does run. So before that, you had to figure out, like go to GitHub.
It failed, but not because build failed. It actually detect made some work and found problems.
Yeah, detect succeeded at finding violations.
Yeah.
So the build failed.
Yes.
So yeah, before that you had to go to GitHub, figure out what's the right incantation to apply the plugin, or go to the Gradle plugins portal. Now with this, you will be able to do that without leaving your IDE, which is a very good improvement. So, still in the spirit of the conventional plugin best practice, let's move that declaration actually inside our conventional plugin. So we have a version here.
Do we need a specific version in conventional plugin? I don't think so. Maybe not.
Do we need what?
Do we need this specific version in the site conversion plugin? We have a version catalog.
We have a version catalog. We should move that to the version catalog. So we will do both at the same time. Move that to the version catalog and move the plugin application to the conventional plugin. So let's remove that from here. I did cut the text so I can reuse it. I go there to my version catalog. I add a detect entry. There is a subtle syntax difference here.
And one more small thing where IDEA could help, and we are aware of that.
All right. I did hit sync there, so from my build logic dependencies declaration, I can get the version catalog completion working, right? And here we go. I get detect here. And then I need to apply the plugin by ID into my convention plugin. Here, I will just add it here. And if I run detect again, detect still succeeds at failing.
Yeah, but at least it ran.
It does run. And I'm back to this sane state of having a single convention plugin that says this is a Spring Boot application.
Yeah. So I believe this is much better than having all the configuration duplicated. Or even like reading such a concise file is always easier. Well, I think that was it for the demo of the basically Gradle editing experience. Let's probably switch back to my presentation. So, quick recap of what we saw here. Yep, we already provide highlighting, navigation, documentation for the Gradle scripts in the same way we do it for other code. Well, because it's actually a Kotlin in the first place, but also because of that like models specifically grabbed from Gradle. That's what you already saw. It's already in production. Version catalogs are also already available. So navigation, IDEA, recognize everything, that's fine. We showed you a couple new things, and namely, you saw dependency completion. That basically allows you to search for dependencies right in the dependencies section. Same thing for plugin blocks. And Paul showed that we kind of cleaned up the completion in general, so you don't get that infinite list of Kotlin things in places where they are probably not that needed. So we kind of narrowed the scope of completion. These are work in progress, not polished. It's just like rough things. We will be doing much more, handling all the stuff, all the problems, logic, adding more smartness there, adding more options there. But here is the direction we are actually going in right now, and we will continue doing so together. And like this kind of is an end for the part of us showing you stuff inside IDE. But as I mentioned, there are a couple other things we would like to talk about today. And it is actually our collaboration in general. Yep. So, as I mentioned, we worked together with Paul. Not me personally.
Not me personally.
Yeah. But we obviously also we two together. But it's not two of us. It's like IntelliJ team working on build tools and Gradle team working on IDEA integrations and
the Kotlin team.
And the Kotlin team working on Kotlin support. So we are working on this for quite some time. I think 5 years more.
More than that. I think the collaboration started a decade ago.
Yeah. So we have a history, and we did a lot of stuff during this year, from things not working at all to the state we basically showing you today. We fixed a ton of bugs on the way. We implemented a ton of features. Gradle evolved a lot. IntelliJ evolved. Well, changes are always hard, so a lot of work there. But more. It's not everything we did. For I think 3 or 4 years ago, we also made a bigger collaboration. We invited Google, namely Android Studio folks, to join us in improving the experience. Android Studio is based on IntelliJ, so we want the Gradle experience be the best in IntelliJ-based IDEs. And IDEas, of course, IDEas.
That's a good idea.
Yeah, it's IDEA should be. I hope so. So we now work even as 3 companies towards bringing the experience to the best. And there are a lot of stuff we are doing together. If you want, we have yearly summits where we gather people from all 3 companies together and discuss what should we do on a scale. If you want to read more of what we have achieved or what we are working on, there was a nice post from Kotlin Foundation, also published in IntelliJ blog about that. But there are 3 specific things we are actively working on right now, and we wanted to talk about them specifically. Let's start with one about sync again. What's the surprise? So, sync. We talked about what sync is and that it might be sometimes long.
And especially that it's an all or nothing process, right?
And it's very complex. So the picture you see, well, you can't read text. I can't, no one else, because it's so many things, so tiny and not so tiny, on both sides of Gradle and JetBrains. that are involved in that process. And we are working actually on resolving the main problem of it, of being all or nothing.
Yes.
Well, could you please maybe elaborate a bit on this?
Sure. So, like you said, there is a lot going on. And the idea with the resilient projecting endeavor is to make it so that any failure that occurs during the process doesn't invalidate all the work. Because currently anything fails somewhere in that diagram, the IDE doesn't get anything at the end. So one step we took is to make the tooling API from Gradle capable of streaming data back to the IDE, so the IDE can start receiving information as it becomes available. And then the IDE can actually start to set up the project in the IDE with the information as it becomes available. Like as soon as you have the build structure, you can already have some things highlighted in the IDE. As soon as you have the sources, you can set up the compilation unit in the IDE and you get code highlighting and so on. And then later on you will get the dependencies resolved, etc., etc., etc. So the process, the idea is that the process is a streaming process instead of a big request response thing.
Yeah, and it delivers multiple results along the way, and IDEA can use whatever is available at the moment to provide you first some information at least, and even if something fails, it would be already able to help you fixing that using the information it already has.
Yep. Yeah, and another aspect to this is that we will need to make some parts of Gradle more lenient toward errors, so we can still continue configuring if something's failed, reporting proper problems to the IDE, and the IDE need to have, like, see some changes also to react to that. Same with the model builders that the IDE ships to IntelliJ, they need to be more resilient. So there is quite a lot of work on both sides that needs to happen. And we started exploring this months ago. And it's, yeah, like Dmitrii said, we are actively working on this.
Yeah. And a nice benefit of this work, it's not the goal per se. The per se goal is actually help with failures. But streaming allows us to be, like, perceived at least faster. So you can start working faster even when some parts are still missing.
Yeah, it's a side effect of this is that the perceived performance will be much better because you will be able to work with your IDE sooner.
Yeah, and so that's one huge direction we are currently working on. It's a lot of technical stuff to do on both sides, but it is not everything. And like there are other areas we kind of acknowledge we could improve. And one of that areas is actually the best practices we have been talking today about a bit at least. Yeah, convention plugin is a best practice. So again, together as a 3 company, we gathered and started a work group towards actually making the official Gradle best practices available. And they are already, base version is published at Gradle site.
Yeah, there is a dozen best practices already published and more coming.
But it's only initial version and we are currently publishing more and more, I think at least once a week.
Something like that, yes.
Yeah, so it's ongoing work. We have a huge list of discussed, even a bigger list of yet something to discuss and like decide if it is a best practice or not.
And
so we
discussed and reviewed and validated.
Yeah, oh yeah. So a lot of like discussed, not just talked. Yeah, we have a lot of work put into that. So if you have some questions about how it's better to do, or maybe what is better not to do.
Yeah, each best practice is structured as should not do this, should do this instead. Right.
Yeah. So go check it out. If you're missing something, feedback us, give us feedback on that. We will be adding more and more and more. And since we are about sneak peeks today, what's more important is it's now a website, right? You need to kind of think about it, recognize you need to go there, find it. And we have an idea. So in future, thanks to these best practices serving us as a solid foundation of things we can definitely recommend, we would be able to add inspections inside IDEA that would tell you exactly that it is not the best practice. Go check it out, or maybe even fix it according to the best practice.
Or adopt best practice. Like, for example, we we saw a demo of how to extract a convention plugin, and it requires quite a bunch of ceremony, right? But the IDE could help. We could have an action to say extract common logic as a convention plugin, for example.
Yeah. So this is a bit more distant future than the sneak peeks we showed you today, but we do have it in I would not say only in minds, but in plans. And the third one, ongoing effort we also would like to highlight today is a Declarative Gradle initiative. And let Paul explain it, as he is leading the initiative on the Gradle side.
Yep, so we've been advocating for a while for people to keep their build scripts as declarative as possible and move their logic to convention plugins, right? So don't have like code and too much logic in your build script, but move that to convention plugins. But there is nothing that enforces that you do that currently in Gradle. And that's one of the goals of the declarative project, is to actually materialize that fence between the build definition that software developers will configure, like adding dependencies, declaring some configuration, and the build logic, which is like how you build. So the tasks, implementation, and things like that be moved to build logic. That's one of the goals. And the other goal is to make the build definition more understandable. Because today, when you look at build definition, you have to deal with a lot of Gradle lingo. You have to deal with source sets, you have to deal with tasks. But most software developers, they don't care much about this. They want to know what is the product that I'm building, and configuring things that are of interest to the software developer, like declaring dependencies and things like that. And so with Declarative Gradle, we're pursuing these two goals. And you can see on the left here two examples of build scripts. Those are prototypes, because this is still an experimental project, right? And so on the top left, you have a very simple Kotlin JVM library. And it's a one-liner.
I want to note, yeah, it's the entire script, the entire build Gradle script, one-liner.
Sure, for a simple Kotlin JVM library. But more important that it's short, it's explicit.
Yeah, so it actually explains what you intend to do.
And you don't say a plugin and an ID, which is the Gradle lingo, right?
Yeah.
You say it's a Kotlin JVM library. And the one on the bottom is a bit more realistic, because you have some things to configure, right? It's a JVM application, you need a main class and some dependency declaration. But one important thing is also that it looks very familiar, right? It's like curly braces, parentheses. Yeah. And that's because this language we use for declarative files is actually a tiny subset of the Kotlin language, and a strict subset of the Kotlin language, meaning that it's valid Kotlin. So it's very familiar. And this language is a very tiny subset, because you cannot use control flow. You cannot use loops. You cannot use functions. It's as purely declarative as we can do. And the language, the configuration language, is based on a schema and document model, right? And that allows a lot of features. Because one of the cross-cutting goals with declarative is toolability. And we want the IDE to be able to make reliable changes to the build script by itself. And with current code build script, where you can have anything because people are free to code in them, it's very hard for the IDE to make reliable changes there. But with a constrained language, it's much easier. And especially if it's strict with strongly typed schemas, it's much easier for the IDE to make changes. And all this is built on top of Gradle existing extensible model and plugins. At this stage, we published an EAP3 last month that doesn't include extensibility yet, but we've been working on that for a while. We have a system that works. We need to iron it a bit in the coming months. To keep in touch, we have a website dedicated to this effort, like declarative.gradle.org, that explains how to use the great IDE support we have for those files.
Yeah, obviously, IntelliJ IDEA and Android Studio do have support for declarative. It's usually requires different build, but they are available, and the site explains where to get them.
Yep. So please try it out. There are samples for Android, Kotlin, and Java builds using prototype plugins, because this is using this requires some changes to the Gradle plugins, of course. And on this website there is also a place for you to provide feedback, and please do try it out and provide us feedback. We're eager to hear from you.
Thanks, Paul. Thanks for kind of discussing, explaining what Declarative Gradle is. And actually, that is it for us for today. We have some time left for questions. Let me see. Let me see what questions we got there.
I hope we have some.
Yeah, we have some. We have some. What do you do if you don't want to apply plugins yet from the convention plugin? Not quite sure what the meaning is. Like, if you don't want to apply, you don't need to, right?
If you don't want to apply a plugin, don't apply it. Like, yeah. Something is probably missing from the question.
Yeah, like the context is not very clear. Well, convention plugin allows you to do different stuff. Yeah, it can be a place where you apply a bunch of other plugins if you need all of them. But you can write a specific logic there, or you can just
configure anything, register tasks. It's build logic after all, so you can do anything you can do with the Gradle API.
Yeah. Well, another one, like, should we not only use conversation setup for multi-model projects?
Sure. So that's a good question. The demonstration we did was on a single module project, right? But the pretext for it was we will add a second application in that build. And that's why we extracted a convention plugin first. And we did not get to add a second application, but that will be the logic next step.
Yeah, definitely. Like, it's not worth of that stuff if you are not reusing it, right? So if you have one model, one build script, like, it's kind of fine having everything in there. The convention plugin is about reusing the stuff, so you don't need to write the same things multiple times.
Yeah.
Well, seems pretty many questions like were kind of answered. Like this one, with a new completion, can I still write logic inside build scripts? Like,
yes, you can. Build.gradle KTS files remain KTS files, so you can still have full Kotlin code there. But what we demonstrated today is a preview, right? And there are multiple ways that this could be implemented.
yeah.
Like, I personally would like to see something, but maybe it's not a good idea. I don't know. We need to have the discussion.
Yeah, like we actually have been arguing about that. My point of view is we want it to be a Gradle completion, meaning that like all the Gradle things should be there, and Kotlin, like, we don't want actually to encourage writing logic there. It's not the best practice actually to write code inside the build scripts. You need to write it elsewhere. And there, of course, you would get all that stuff.
But you need people to still be able to. So
in some places. Yeah, like, that's actually what we have been arguing about. Like, we will be adjusting it based on your feedback. So if you do want to write Kotlin still there in every places, like, it can be implemented. Like, on the first invocation you have basic, extended one gives you as it used to be. For example.
You mean like I trigger completion once, I get the restricted completion.
Yeah.
If I trigger it again, then I get the full one,
Yes,
for example.
Something like that. Maybe. Or maybe like we just specifically design which constructions you need there and we allow them. Otherwise, like, if you want, you can copy it from somewhere, it would work, but the idea would help you do bad things.
It's an open question.
Yeah, it's an open question, but like, still, thanks for asking. Yeah, what else? Like, we have some time left. Maybe we can talk a bit about the dependency and plugin completions. Yeah, so we showed you how it works. But the question is, what are those suggestions? Where do they come from? Well, it's a server-based stuff. So we will be making a service that has all that stuff and streams it into the IDE. That service would actually, of course, like the source of truth for the list of artifacts is Maven Central. Everyone knows it. And
Maven Central.
Yeah, and like other repositories that are registered for you. But like if it's your personal one and we have that basic server in the cloud, of course, it won't be able to. So at the first step, definitely, it would be packages from Maven Central, streamed through our service for like availability and other stuff. Gradle plugins go also through our service, but they are streamed from the Gradle plugin portal. So the main point I actually want to highlight is that that information should be there like almost live. So it should always have the latest versions and the latest plugins, like maybe with some delay, but like it's not your local M2 cache. It's like it's a server-based one.
So IntelliJ actually queries a service that you run. That indexes the repositories and provides the
that's the plan.
The up-to-date data.
That's the plan. That's how we actually designing this.
Cool.
So quite a lot of work there on the server side, inside IDEA. Like, but we're happy we have some working things already to show to you today. Well, couple more minutes. Well, before I actually offer you, as I should, to subscribe to all our social medias, like especially LinkedIn, since we started there recently, but yeah, you know, all other stuff. Maybe we can also discuss some other things in regarding our collaboration. So, for example, the best practices. Yeah. So we have been working on this for some time. Again, it appeared from the summit. Like, but maybe
we started the working group for best practices in October, November last year.
Yeah.
And we published the first best practices a month ago.
Yeah.
So it took a while to like get agreement and and refining.
A lot of arguing there, right?
A lot of arguing.
So
and to refining the documentation to like explain the don't do and do, etc.
Yeah.
And we have a backlog, and we are processing this backlog.
Do you have your favorite one, except the convention plugin you showed?
I will say the convention plugin one.
So
no, except this one.
Except this one.
Except this one. Use the Kotlin DSL. Use the Kotlin DSL instead of the Groovy scripts, because thanks to the IDE support of the Kotlin DSL, it's much easier to navigate to source, to understand what's happening, understand the underlying Gradle model, and so on.
Yeah, so strictly typed languages
Yes.
are much better and much more toolable. So for us, they are also much better to work with. Like Groovy is good, but from the IDE standpoint, it's much easier to work with strict types. And we do want to provide you with all that smartness, and it's kind of a bit easier for us. For example, if we are going to introduce those quick fixes, like let's do best practice for Kotlin DSL, and especially for declarative, it would be much easier for us to implement that. So, like probably Groovy might get some, but might not. Kotlin would
probably will get less.
Yeah, at least probably would get less. Kotlin would get more because of it's being a strict type thing. And like we are out of time. Thank you everyone for joining us. Thank you.
Bye bye.